All right, let's talk about combining like terms. Combining like terms involves knowing what like terms are. What is a term and why are they alike? Why are they not alike? So a term could look like any of the following things. It could look like a number by itself. Oops, let me turn on my pen here. So it could look like a number by itself too. It could look like a number with a letter. Or it could look like a letter by itself. What do we call these letters? Well, we call them, in mathematics, we call them variables. And every single one of these things are called terms. Okay, so that's all three of these things are called terms. So the numbers by themselves in mathematics are called constants. And then when we have a number next to a variable, we call those numbers coefficients. So numbers by themselves are called constants. Numbers with the variables are called coefficients. So yes, the x is still called a variable, even though it's with a number. So those terms I'm going to keep using. We have numbers by themselves, which are constants. Numbers with variables are called coefficients. And the letters, the variables, are called them. Let's talk about like terms. What makes a like term? Well, if I were to give you that term 2x, I'm going to show you like terms and not like terms. There's two main things that make something a like term. A like term has to have the same variable and the same exponent. So I could have any number as long as it has x after it. And those could be considered like terms. 3x, 4x, 5x. Negative numbers also work. Decimals. Fractions. I could have any coefficient in front of my variable as long as my variable is x. That is a like term to 2x. Not like terms. If I had 3x squared, 2x squared, 4x squared. You see what's different about those? They have x's, but they have a power of 2. Just like if I had 3x to the third power or 2x to the third power. These are not like terms. Do you notice how the 2x squared and the 2x cubed have a 2 as the coefficient, but they're not like terms? When we're talking about like terms, we desperately need the variables to match, but the coefficients, they don't matter until we start combining. When we're determining what a like term is, we are only looking for the variables to match. So here's some others that don't match. We have 5y. That's a different letter, just like if I had 2z or 4b. These do not match because they have different letters. Trying to think of some others. I think that's pretty much it. So we're looking for it to have the same variable meaning the same letter and the same exponent. There's also an invisible one with each of these x's. So with each of the x's by themselves as a variable, it has an invisible one as its exponent. That's kind of important to know just so that you can visualize why these are different, because x to the first power is a heck of a lot different than x to the second power or x to the third power. So that is why they are not like terms. Okay, so we've talked about what terms are. We've talked about what like terms are. We've said that it has to have the same variable and the same exponent for it to be a like term. Now let's start combining like terms. So let's look at an expression. I'm going to start small. 3x plus 2x. If I'm combining this expression, I have like terms in front of me because 3x and 2x only have x as their variable. These are like terms. And because they are like terms, I can combine them. So if they are like terms, I can combine them. I'm going to add only the coefficients together. 3 plus 2. 3 plus 2 equals 5. And my variable is x. I'm going to keep my variable the same. My variable will not change. The only thing I'm adding is the coefficients. So I have 5x as my answer. So 3x plus 2x is equal to 5x. The only thing I did was 3 plus 2, and then I kept x the same. Let's do another example. So if I have 4x squared plus 2x squared, what would that then be? What is my variable? Well, my variable is x squared. My variable is x squared, not just x. When I'm talking about variable, that includes my exponent. So then I'm going to keep my variable the same, which is x squared. And then I'm going to add my coefficients. I'm going to put that in a different color so I can keep them separate. I'm going to add my coefficients together. So I have a positive 4 and a positive 2. When I add them together, I get 6. So 6x squared is my answer. So 4 plus 2 is 6. I keep x squared the same. Okay, let's make it just a tad bit more complicated because it always gets a little bit more challenging as we go forward. Let's write out this expression. So I have 3x plus 4 plus 6x minus 3. Pop quiz. What's a number that doesn't have a variable next to it? What is that called? It's a constant. Good job. A constant is a number without a variable next to it. Okay? The number next to a variable, what's that called? That's a coefficient. Nice. Okay, so we are just remembering what those are called. Okay, now let's talk about like terms. I see some like terms here, do you? I see 3x and I see 6x. Those are like terms because they both have an x next to them. And only an x. It's not x squared. It's not x to the third power. It's just x. So we have like terms. 3 plus 6 is 9. And I keep my variable the same. That does not change. Then I have my constants. All constants are like terms with each other. So that means my positive 4 and my negative 3 are going to be combined together. 4 plus negative 3, in other words, 4 minus 3 equals 1. And that's a positive one, right? When we have 4 minus 3, that equals a positive 1. So we have a positive 1 left over. Now, can I combine 9 plus 1 here at the bottom? No, I cannot, because they are not like terms. Something has to be a like term for us to add them together. Because a 1 is a constant and 9x is a term with a coefficient and a variable, we cannot combine 9x and 1. It just stays like that. That's our answer, 9x plus 1. We're simplifying expressions. That is what we're doing. We're simplifying expressions by combining like terms. Okay, let's do another example. This one's a little bit more challenging. Let's do it. 9y squared plus 4y minus 3y squared plus y. Okay, so we need to find our like terms first. And you might be saying to me, Mrs. Collins, they all have y. Aren't they all like terms? And I would say no. These are not like terms. We have 9y squared. We have 4y, negative 3y squared, and a positive y. Those are not all like terms. We have 9y squared. This is a term. Then we have a y by itself. Then we have y squared and a y by itself. Okay, let's use blue here. So we have 9y squared has the same as negative 3y squared. They don't match 4y or y because they don't have to the power of 2. So we have 9y squared plus negative 3y squared. So 9 plus negative 3 is what we're figuring out here. 9 plus negative 3 is the same thing as 9 minus 3. Okay, 9 minus 3 is equal to 6. And what do we do with that variable? We put it on the end. We don't change it. It stays the same. So 6y squared is going to be what 9y squared plus negative 3y squared is equal to. Then we have our last terms, 4y, it's a positive 4y and a positive y. Let's talk about this y. How many y's do I have there? I have 1. 1 y. So therefore, the coefficient that goes in front of a letter by itself or a variable by itself is 1. If you see a variable and it's by itself, it has an invisible coefficient of 1. Say it with me. If you have a variable by itself, it has an invisible coefficient of 1. Okay, so therefore, we have 4y plus 1y. 4 plus 1 equals 5. And then we bring down our variable. It does not change. It stays y. And then it is a positive 5. 4 plus 1 equals positive 5. So we're just going to add that positive there. If it was negative 5, then instead of an addition sign, you would have a subtraction sign, right? Okay, so I'm going to box this in because guess what, folks? We just answered another problem. 6y squared plus 5y. We can't combine them together because y squared and y are not like terms. And that is all for that one. We just did another problem. Let's do one more. Maybe 2 more. Let's see. Okay, this one's going to have some fractions. Fractions, fractions. We love fractions. And there we go. So I'm looking at 3/4 x plus 1/4 x minus 3x. What do you notice about this problem right away? If you said that they are all like terms, you are correct. They all have x. And those x's don't have an exponent attached to them. Well, they do. They have an invisible one. But they're all the same, right? They all have that x to the first power, an x with them. That means they are like terms. So when we combine these, we can combine all of the terms together. Let's start with 3 to the 4th power. 3 to the 4th power, what am I saying? 3/4 plus 1/4. we can combine those things because they are like terms. We're going to keep x the same. 3/4 plus 1/4 is equal to 1. So 3/4 x plus 1/4 x equals 1x. 3/4 plus 1/4 equals 1 whole. Okay, and then we have this term left over. We have our negative 3x left over. So minus 3x. What do we do here? Well, we know what to do. We keep our x the same, and then we handle our coefficients. 1 minus 3 is going to be what we're doing here. 1 minus 3, not 3 minus 1. 1 minus 3, it makes a difference. 1 minus 3 gives us negative 2x. When I was teaching this in class, some of my students were freaked out that we got a negative answer here. But negative numbers are okay. We can have negative numbers. That's fine. This is our answer. We combined like terms. First we did 3/4 x plus 1/4 x, and we got 1x. Then we subtracted 3x, and we got negative 2x. That's all. If you're not confident with fractions, I recommend using that calculator. Calculators are made to help us with things like fractions and decimals, so don't be afraid to use it. Take a look at my fractions calculator video if you need help with that as well. Okay, so one more. Let's do one more together, okay? So I'm going to write it out, and I want you to, after I write this out, you're going to pause, and you're going to try to solve this problem, okay? So after I write out this problem, you're going to pause and try to solve and see if you then get the same answer as I do, okay? So here's your problem. Go ahead and pause. Okay, so let's solve this problem and see if you got the same answer as me. First, I'm going to find my like terms. The first thing I see, 0.5x. This is a positive 0.5x. And as I look through the rest of my terms, I see one like term. That is a positive 2.3x. So I'm going to combine those first just to get those out of the way. 0.5 plus 2.3 is equal to 2.8. Okay, and then I keep x the same. So I have 2.8x. Okay, so let's look for some other like terms. I see a positive 2.1y, and I see a positive y. Remember, it has an invisible 1 as its coefficient. So I'm going to combine those next. I am not combining my negative 4y squared with that because y squared is a different variable than y by itself. So here I have 2.1 plus 1 equals 3.1. And I'm going to keep my y the same. And then I just have my last term. It does not have any like terms, but that's okay. We still love it just the same. So now I'm going to write out my final expression because I've simplified everything. So I have my new 2.8x, and I have a positive 3.1y, and I have a negative 4y squared. So I could write plus negative 4y squared here, but it's the same thing as minus. When you type in your calculator plus a negative number, it's going to do the same thing as if you were subtracting. Okay, so plus negative is equal to subtraction. So this is our final expression. Okay, 2.8x plus 3.1y minus 4y squared. That is our simplified expression. And that's all we have for combining like terms. If you can do this, you can combine like terms and simplify expressions. Nice job.